So we saw problems like this from last time. So we can see, for example, the first thing I would probably notice here is that I got this 49-degree angle, and then there's this angle that's opposite to it through the origin, through the vertex rather, which makes these vertical angles. Okay, since they're vertical angles, it means angle C here is 49 degrees. All right, that's pretty good. But what about angle B? Well, I can see that it creates a straight line with a 49-degree angle, meaning that angle B here, that I put in green, and the 49-degree angle make up a supplementary relationship. So this means if I were to take the 49-degree angle and also angle B, if I were to add them together, I get 180 degrees. So this is just the principle of equality needed to solve this. One principle of equality, so I'll subtract 49 from both sides, and we see that solves for angle B. So the 49 zero out. I've dropped the angle B. 180 minus 49 looks like it's 131, and since this is an actual angle here, I'll label it with degrees. So angle C is 49 degrees, angle B 131 degrees. All right, looks like we got two objectives. I can identify special angle relationships formed by transversals, and also I can solve for missing values in special angle relationships. So take a minute and copy that down, and we'll get started. Yeah, we'll see again in this lesson that there's a lot of vocabulary that's going to be needed in order to understand what's going on here. But once you understand the relationships, then you won't necessarily need the vocabulary. You'll just be able to visually see some of the relationships and be able to solve the problems that way. All right, first up, so parallel lines. And I think most people your age know already what parallel lines are. Just as a quick review, they're just two or more lines that if they continue forever, they just never touch, okay, or come together or intersect, however you want to say that. The nice thing about parallel lines is we've seen these before when we went over slope and slope-intercept form of equations of straight lines, and we saw that when the slope is the same, that we could end up with parallel lines, although there were some times where they were just the same line, okay? And you could even say that they're parallel, but we'll skip that for now. Now you can say that two lines are parallel using these symbols. Like this one, it's just a double slash mark. Sometimes these even kind of show up as just straight up and down lines, like this. Doesn't really matter. Or if we see it on a diagram, so this is just writing regularly that two lines can be parallel. For example, if I had line segment, and remember we talked about line segments last time, so line segment just has this line above it. And maybe we have some other kind of ray, right, like C and D. So if it's a ray, then it has one arrow on it. I can say these two lines are parallel. These two types of lines are parallel with just a symbol like this. But like I said, in the past, it's possible you may have seen them slashed like this. Doesn't matter. Both indicate that the two types of lines are parallel. Now, on a diagram, though, we would see that not just the arrows regularly, but they'll kind of emphasize other arrows on the lines. So if I were to draw a line, and I'll use some technology to make this look good, like this one, and well, let's pretend like I'm drawing a parallel one. It looks pretty good. Okay, now if we made these lines with regular arrows like this, then what they'll do to show that the two lines are parallel, they'll just put an extra set of arrows on them. If it's colored, generally speaking, these would be red like this, okay? Sometimes they're even filled in. Doesn't matter as long as we see those. These two marks right here indicate that we're looking at a set of parallel lines, okay? Now this is going to be important when we understand or can identify, like we saw on the objective, when we can identify special angle relationships. Parallel lines create a unique scenario there for us, and then it's generally it's very easy for us to figure out as long as we can solve equations, but just identifying them is usually good enough. All right, so a transversal is a line that goes through two or more other lines. It just can't go through the two or more other lines at the same point, okay? And then this creates an exterior and interior relationship. Exterior would be considered the outside of the lines, and the interior would be the inside of the lines. Usually, when we're talking about exterior or interior, it's not in relationship to the transversal, okay? Now, this is new vocabulary for us, so what the crap am I talking about? Well, if I were to give myself a couple lines here, and these ones don't necessarily have to be parallel, it's just if they are parallel, then it creates a special relationship with these, with the transversal, okay? So right here, I will name this, the black line here, just line A, and then the red line, just line B, okay? Well, if I gave myself another line going through these two, this one, I could label it line T, T for transversal, and this purple line that I've created, since it goes through line A and B, not at the same point, it's considered a transversal for lines A and B. And you can even flip this, right? You could say, well, what about line A? Could that be considered a transversal? Yes, it could. It's a transversal for lines T and B. Now, along these lines as well, is you got lines A and T, and B would be considered a transversal for those two lines as well, even though it's not showing that it's going through this, I guess you could call it line segment A. But if we were to continue these two lines, line B and A, eventually they will connect over here. You just can't see the connection right now, okay? So B is a transversal for lines T and A. A is a transversal for lines T and B, and T line is a transversal for A and B. Okay, now I just want to focus here on T, or line T, being a transversal for lines A and B, okay? All right, so again, these exterior and interior stuff is not in relation to the transversal themselves, okay? Which means that if I was looking at exterior, I would be looking at the outside of lines A and B, okay? So I kind of look at it like a sandwich, and that's not just because I'm a fat guy, it's just because I like sandwiches, okay? But exterior would be the outside. So this area here would be considered exterior. And this one here also, exterior. And it's possible you've heard the word exterior before. You probably knew that it was outside. If it's new to you, all right. Now you know it's on the outside. Interior, though, is the inside. And I kind of remember this I for inside, I for interior, whatever. But it's inside the two lines, right? So inside here, well, not inside, but interior. And we have to be able to identify exteriorness and interiorness of lines like this, okay? Now, remember, I'm pretty much ignoring line T right here. So whatever line you're considering the transversal, ignore that one when you're looking at interior and exterior. Then we would identify angle relationships that are created from the transversal. All right, the first special angle relationship formed by transversal, okay, is what we call alternate interior angles. And we got three conditions here, right? And I guess it's kind of written in this language right here. So alternate means that I guess you could say that they're on opposite sides of the transversal. But to me also it would include this first one, angles that are different vertices. Vertexes, whatever. But interior, of course, means that they would have to be on the inside. This is usually the first thing that I would identify, interiorness. Okay, I would look for interiorness first. Then I would look for alternatingness second, okay? And yes, we've seen angles plenty. So we should be able to identify those, okay? Now down here at the bottom, like I said, if the two lines are parallel, then it creates a special relationship with alternate interior angles that makes them congruent. And because congruent is kind of a new word for us, it just means that they're the same, okay? So if I were to give us a diagram here, not that I think you'd want one, but here we go. So if I had this line right here, and I'm not going to make these parallel. Okay, so I got these two lines. I'll call this line again A and this one B. But if I had a transversal going through these, again I'll call it line T. By the way, I'm using T for transversal just so we know which one is the transversal, but you wouldn't have to. You could use whatever letter you want. If I were to identify alternate interior angles, again, I would have to look on the inside first. Okay, so I know the inside of the two lines, not the transversal, that is our interior, right? So if they're already on the inside, they've got to be one of these two angles or one of these two angles right here. Those are the inside angles. Okay, and now they got to be at different vertexes. Well, we got two vertexes, right? We got this one and we got this one. So they have to be in different vertexes. But then also, they'll need to be on opposite sides of the transversal, okay? So that means if I were to look, again, it has to be on the inside, right? So for this vertex, I could identify this angle. Okay, so I've got to go to the other vertex, and it has to be on the other side of that transversal right there. Okay, so that's that other blue one. These two right here that I've marked are alternate interior angles. But of course, there are more. You may have identified this one as well. See if I can get in there. Some of you may have identified this one in purple. It's alternate interior with this one as well, okay? Now, I'm not worried about the parallel line thing. We'll deal with that. Right now, all we just need to notice is the relationship. Okay, are they alternate interior angles, and then we can consider if the two lines are parallel. Of course, if they are, they'd usually tell us in the beginning. Okay, but they have to be on the inside at different vertexes and on opposite sides of the line. Okay, so that's alternate interior angles. Which, if we say alternate exterior angles, everything is the same. We still have to be looking at angles at different vertexes, and they have to be on opposite sides of the transversal. They just have to be on the outside of the diagram, okay? So let's give ourselves a couple lines. Again, I'm not focused on parallel lines just yet. We'll get there as much as you want it. So I got this one here, and again, just kind of a similar one here. We'll call this line A and line B again. And yeah, line segment, doesn't matter. So just right here, I know the outside of these two lines, because remember, I don't really care about the transversal. The outside of these two lines would be here. And yeah, I'm saying outside instead of exterior, doesn't matter. And the outside here and the bottom as well, right? In between the two lines would be considered the inside. Now that I have that, let's give ourselves a transversal here. And again, I'll call this line, or you could say line segment T if you wanted. All right. So we have the two vertexes, the two vertices here and here. And we know that alternate exterior angles have to be on the outside of the two non-transversal lines. So if I wanted to identify just one of those here in the top, I could identify this one right here, okay? Now, the way I'm looking at the transversal, I would say that's on the right, which means if I go to the other vertex, it has to be on the outside, and the angle has to be on the outside, but it has to be on the left side. These two angles that I've marked in blue are considered alternate exterior angles. And the same is true for these other two that I'm going to mark. So on the outside of the top, you could go to the left. That's this angle. So I'd have to be on the outside of the other vertex, but on the right here. So these two purple angles also that I marked are considered alternate exterior angles. And again, if lines A and B were parallel, then we would know that the two angles that are alternate exterior are congruent. They're the same, okay? All right, next up, and this is pretty much our final special angle relationships, especially when we look at parallel lines, is corresponding angles. So corresponding angles, they have to be at different vertices or vertexes, but they have to be in the same location of the different vertexes. Okay, so what I mean by that is if one's on the bottom left, then the other one has to be on the bottom left. If we're looking at an angle that's top right at one vertex, we go to the other vertex and say the one at the top right is considered corresponding with the other, all right? It's just if the two lines, again, that we're considering, if they're parallel, corresponding angles also congruent. Okay, so if we were to see parallel lines, corresponding angles, alternate exterior angles, alternate interior angles are all congruent. They're all the same, which is nice because I think it makes things easy for us to solve, but we'll see. All right. So here, let's go ahead and give ourselves a couple lines here like this, and they're not parallel. They're not meant to be anyways. And I'll even make the transversal go a little bit different like this. All right. So labeling these, I'll say this is line A and B. And then my purple one here is line T. With corresponding angles, I don't care about exteriorness or interiorness, which you may have noticed for the two conditions we need for corresponding angles. They just have to be in the same location at different vertices. So here's one vertice right here in red, and here's another one right here in red. Okay, two vertexes, two vertices. Remember, vertices are just where the two lines intersect. So if I look at the top vertex right there, and I'll just mark it. Well, we've already marked it in red, but what I'm looking for is I'm just going to go to this one right here, this angle, okay? Now, that is on the exterior of the two lines, the two black lines right there. But again, I need to identify its location in relation to the vertex here, right? So for me, I'm going to say that's up and to the right, so top right. Okay, so this angle is top right. And that's important because corresponding angles are going to be at different vertex. Well, I do have a different vertex here, but they're going to be at the same location of the different vertex. So that means down here, the corresponding angle has to also be top right. Okay, so that means that I can go in here and say, look, these two angles right here, I'm going to mark it blue again, just so we know that they are corresponding. These are corresponding angles. And notice that this has nothing to do with exteriorness or interiorness. All it has to do with is location with relationship to the vertexes, okay? So if you wanted to, you could say, well, top left, right? Well, that'd be this one that I'm going to mark in green, this one. Well, what about the other vertex, top left, right? So that's this one, okay? So top left, those are corresponding. You can also say bottom left and bottom left. Those are corresponding, or bottom right, bottom right. All four would be sets of corresponding angles. But the unique thing is if those two lines are parallel, these two black lines that we have here, the transversal goes through them. If they're parallel, the corresponding angles will be congruent. In this diagram, there's lots of transversals and lots of non-transversal lines. But we're going to identify these angles, and then we'll figure out what type of relationship exists. But you can see on this that they're looking at vertical angles also, which we learned last time. And then on this, it says straight angles. When it says straight angles, we're looking at supplementary angles, okay? That's what straight angles are. It's just the two angles have to form a straight line. That's it, okay? So if I look at angles 1 and 8, I'll start with angles 1 and 8. Here, there's angle 1 and then angle 8, okay? Now what I would want to do at this point is pretty much ignore the rest of this stuff. Okay, meaning, I don't know, you have to mentally be able to block this out or just kind of erase it from your mind. Because if you look at angles 1 and 8, what we end up with is a diagram. It's not perfect, but we have this line here, and then we got kind of two lines like this, right? Well, angles 1 and 8 are here and here, okay? So I can see that I have a transversal, right? The two angles have to be part or on the same line. That whatever line that is going to be the transversal. So that it looks like that's line S on the diagram. But these two then are on the exterior of the two lines that are not transversals, and they're on opposite sides of the transversal. That makes angles 1 and 8 alternate exterior angles. So I just say, hey, down here, boom. Angles 1 and 8, alternate exterior angles. All right, well, let's do 12 and 11 then. Here's angle 12, here's angle 11. Well, these two form what I would see here is a straight line. These two form a straight angle relationship. Or you could say supplementary, but straight angles is good too. And by the way, these two, since they are straight angles, if we knew one of them, we could solve for the other. Because, just like we did on the billwork, by the way, because we know that the two have to add up to 180 degrees. All right, how about angles 13 and 21? So there's angle 13, here's angle 21. Again, I would look at line T here as the transversal, going through lines R and Q. Like angle 21 here would be considered on the inside, 13 is on the outside, so they can't possibly be alternate interior or alternate exterior angles. But what I do notice here is that at this vertex and this one, that's just straight up from there, which means that these two are corresponding angles. Now let's look at angles 14 and 15 then. So here's angle 14, here's angle 15. I see that these two are through the vertex, which means that these two are vertical angles. And that's a relationship that we saw during the last lesson. Next up, 7 and 14, angle 7 here and angle 14 there. Well, these two are part of this line, so that's our transversal, and I can see they're sandwiched between line S and R, meaning that these two are alternate interior angles. Now again, they're alternate because they're on opposite sides of that transversal too. Next up, angle 9 and angle 20. So once again, I can see that these two are part of this transversal line U, which means I'm looking at R and Q lines. And I can see from those two that they're on the outside, okay? And they're on opposite sides of the transversal, meaning that these two are alternate exterior angles. And yep, they are also at different vertices. So automatically, alternate exterior angles. You'll notice here that we're not actually calculating anything yet. We're just identifying these relationships. Next up, angles 5 and 7. So here's angle 5, here's angle 7. All right, so again, they make this straight line here. That means that they are straight angles. Which, again, is kind of a relationship that we saw last time. We just called it supplementary is all. How about angles 22 and 23? Well, these are through the vertex. So these two are vertical angles. Angles 1 and 5. Here's angle 1, here's angle 5. So these two are connected with line S at these different vertices. So we're looking at lines T and U as the non-transversal lines. So line S is the transversal. But I see that if I look at this vertex, that line or angle 5 is just straight up from there, and same with this vertex, angle 1 is straight up from there. That means they're in the same position of different vertexes, which means that these two are considered corresponding angles. And finally, angles 21 and 8. Here's angle 21, here's angle 8. And a lot of students in this one get confused by this line R. Again, we're ignoring it because it's not part of our angles, right? But I do see that angle 8 and 21 are connected with this line T, which means it is our transversal. That would also mean that lines S and Q would create an inside relationship here in this area. That's where angles 21 and 8 are. So they're on the inside, they're on opposite sides of the transversal and at different intercepts or vertexes, which means that these two angles, angle 21 and 8, they are alternate interior angles. There we go. Okay, now again, this is our first objective, just being able to identify these relationships, because if we can, then we can solve problems that relate to these. Now let's consider the parallel relationship of the non-transversal lines. Okay, so now we got angles 1, 2, 3, 4, 5, 6, 7, and 8. Right? Sometimes we can number the angles, that's fine. But what happens is if two lines are parallel, then alternate interior angles, also alternate exterior angles, and also corresponding angles, they are congruent. And because it's possible that we may have forgot that, congruent means that they are the same. All right? This is incredible because all we need is one angle and then we can solve for the rest of them. Meaning, if I set up here at the top that angle 1, let's just say that angle 1 here is 100 and, well, let's just say 100 degrees, okay? Well, if it is 100 degrees, I'm not saying it is, but let's say that it is. Okay, well, what I would know, let's start with the alternate interior angles. Well, it's not interior, so I can't actually use that one, so skip that garbage. Let's look then at alternate exterior angles, because I do identify angle 1 as being on the exterior. Okay, so what would its alternate exterior angle be? It'd be angle 8. Okay, that means that angle 8 also has to be 100 degrees. How do I know that? Because lines L and M are parallel. How did I know that? Because of the angle, the arrow marks right there. Of course, it's possible on the assignment, you just may see line L is parallel with line M. Something like this. Is there another relationship we can find with angle 1? Yes, there is. Angle 1 and angle 5, they're in the same position of different vertexes, which means that these are corresponding angles, which means also that angle 5 would have to be congruent to angle 1. It also is 100 degrees. Some of you may have said that angle 5 and 8 are vertical, and that's true, which makes them also congruent. And so we see a relationship then between 1 and 4. Angle 4 there also has to be 100 degrees. And there's two reasons for that. It's alternate interior with angle 5, which we already know is 100 degrees. It corresponds with angle 8, and it's vertical to angle 1. Any one of those three reasons is good enough to say that angle 4 here is 100 degrees. Then also, you could say, look, we got this straight line right here. That's going to allow us to solve for angle 2 because angle 1 and 2 create a straight line. They're supplementary. So you could say, solving for angle 2, you take 180 minus 100 there. And I'm skipping some math there, but that means angle 2 would be 80 degrees. All right, well then it's vertical angle also, 80 degrees. And its alternate interior angle there with angle 3 is also 80 degrees. And the angle vertical with that one is also 80 degrees. Okay. So like I said, you only need one angle in order to solve for the rest of them because the lines are parallel. If they're not parallel, we can't make these conclusions except for with the vertical angles. All right, determine the angle relationship of the following angle pairs. And these two lines, L and M, are parallel. That's great, okay? Let's identify where these are. Angles 1 and 3, right? Angle 1, angle 3. Well, these aren't actually, that's not one of those special angle relationships that new ones that we're talking about today. Angles 1 and 3 there, they create the line, the transversal that I'm looking at, which means that these two are just straight angles. But again, if you said they're supplementary, that would work. All right. Well, how about angles 4 and 6? Well, there's angle 4, there's angle 6. Well, these two are on the interior, right? But see how they're on the same side of the transversal? So they're not alternate interior angles. However, you may notice that angle 6 and angle 2 are congruent, right? If you look at angle 2 there, angle 6 and 2 are congruent. So that also would mean that angles 4 and 6 would be supplementary or straight angles. Okay, and that'll be crucial because sometimes they'll do that to you. They'll say, what is this relationship? And it doesn't look like they're right next to each other, which they aren't. But since angle 6 and 2 are the same, because the lines are parallel, that makes them corresponding, and corresponding angles are congruent when lines are parallel. Nice. How about angles 8 and 5? Angle 8 and angle 5 here, well, they are through the vertex. And if they are opposite through the vertex, that makes them vertical angles. Now, if you said angles 4 and 6 were interior, I would accept that because they are, but they're not alternate. They are not alternate interior angles. All right, so with a diagram like this, it says angle 4 is 105 degrees. Nice. Well, since we know angle 4 is 105 degrees, I'll put the mark here, and I will label it as 105 degrees. If you don't like the writing right there, then don't do it. You don't really need it. Or some people don't need it, I should say, but I like to see it there, okay? Now, as for me, I would start with 105 degrees and just look at any of the angle relationships that exist, okay? The other thing as well is that we notice that lines L and M, they are actually parallel because of the red markings here with the lines. Excuse me. So, is there any angle relationships we can relate with angle 4, which is 105 degrees? Sure. Now, it doesn't matter which one you start with. I'm going to start with angle 5 right here. Angles 4 and 5 are alternate interior angles. And since the lines are parallel, that makes them the same. Angle 5 is 105 degrees. They are congruent. Now, you could say angle 8 is vertical with angle 5. That is true. But because I want to focus on the special angle relationships, angle 8 is corresponding with angle 4. They're both, I would say that's the bottom right of both vertexes, which means angle 8 also is 105 degrees. I'll fill in the blanks later, by the way. And then, again, just focusing on the angle relationships, some of you may say angle 4 and 1 are vertical, so they're automatically congruent, which is true. But since I'm focusing on the special angle relationships, angle 8 and angle 1 are alternate exterior angles, which makes them also congruent, 105 degrees. So that gives us those 4. We know angle 4 was already 105 degrees, but now we know angle 1 also 105 degrees. Angle 5, 105 degrees. And angle 8, 105 degrees. So we just need those last 4. But what we know here, just identifying the relationships, is that, I'll start with angle 2 right here, okay? Well, angle 2 is corresponding with angle 6, so they are the same. And I'm using the same colors here so that we can remember that. Angle 2 is on the exterior of the two lines, L and M, which means angle 7 is exterior, but it's on opposite sides of the transversal. Since those two lines are parallel, that makes them the same. And then again, just focusing on the special angle relationships, angle 6 and angle 3 are alternate interior angles, which makes them the same. They're congruent. Some of you may have said that angle 3 and 7 are corresponding, which is also true, so they're also the same. But again, if you said angles 2 and 3 are vertical, so they're the same, yeah, that works, okay? We just got to figure out what that is. So, here's what I know. Angles 2 and 4, that's the two I'm focusing on. They create this straight line, and yes, I know I suck at drawing a straight line, but I did my best there, okay? But, angle 2, do my work on the right here, and angle 4. Since they make that straight line, if I were to add them together, I should get 180 degrees, okay? I don't know the measure of angle 2, but I do know the measure of angle 4. So instead of writing it as angle 4, I can say that this one, angle 4, is actually 105 degrees. And then I just solve this equation for angle 2. Not too bad. So one principle of equality will do it. So I will go ahead and subtract 105 from both sides of this equation. But we'll do it right this time. So 180 minus 105. You can see why I would recommend using a calculator right here, but that's going to be angle 2, 75 degrees, okay? So again, I like to see these on my diagram though, so I will. Angle 2, 75 degrees. Angle 3, going to be 75 degrees. Again, that's because we've already identified those special angle relationships, 75 degrees. And now I can go in and just label all these ones, 75 degrees. Okay, and this solves all 8 of the angles. I guess we didn't have to solve for this one, of course. But that's as much as we had to do. And again, notice that there's only 2 different measurements here that we had to find because of these special angle relationships. You're going to see more stuff like this on the assignment than just identifying those angle relationships. But if you can't identify those relationships, then it can make it more difficult. Well, there's our objectives. I can identify special angle relationships formed by transversals. Remember, they don't have the 2 lines do not have to be parallel, but if they are, then we can actually solve for missing values with those special angle relationships.